Okay, let's take a look at sort. So sort will take an array of values and sort them. And if they are strings, it will sort them alphabetically. Otherwise, it'll sort them by value. And actually, just to show you how this is working, I've created a new array here and given it two colors that start with B and L. So the way that this will work is it will sort on red and blue, and it will go through. By the time it gets to the comparison between blue and black, it will look at the B's and see that they're identical. So it knows that it needs to now sort by the next character in the string. If they weren't identical, it would just stop at analyzing the first character, but because in this case they are identical, it goes on and it looks at the second character in the string and it sees that they both equal L. So it goes on again and it looks at the third character and determines that A is before U, and so then black gets swapped before blue in the final result. And we can look at how this works on an array of integer and float values as well. Now, this is going to be interesting. So look at this. Negative 54, 0.42, 10, 150, and then 2. So everything was good up to the 2. Why did it put the 2 back here instead of before the 10? And the reason is because it got here to the 10 and it compared that against the 150 and it said the 1 and the 1 are equal. So it looked at the next digit and it said 0 comes before 5, and so the 10 got put before the 150, which happened to work out in this situation, even though it didn't analyze the 0 at the end of the 150. But by the time it compared these two, 150 and 2, it said, well, 1 comes before 2, and then just stopped there. And so how do we work around that? Well, the sort method allows you to pass in a comparison function. So in this example, I'm creating a shorthand arrow function with an implicit return of the result of taking A and subtracting B from it. So every time we pass in a comparison function, we know that we'll have A and B to work with. B is the current value and A is the prior value. That's one way to think about it. So in this case, the very first time that the sort method will start analyzing this array, B will be 150 and A will be 10. So we're going to take 10, subtract 150, and we get a result of 140. Now, how is that going to do us any good when it comes to sorting? So all that the sort algorithm cares about is whether the number is a negative, positive, or 0. If it's a negative number, then it will sort A before B. If it's 0, it will leave them as they were because they're already sorted. And if A is a positive, if it's a positive result, then the element B will be sorted before the element A. And internally, JavaScript is using a sorting algorithm to do this. However, there's a possibility it could be different between browsers, and it's actually a much deeper topic than we have time to go into in this tutorial. So for now, I don't want you to worry about the exact algorithm it's using to step through these and compare them. Just know that every time it does, it will give you two elements to compare against, and you'll have to return either a negative or a positive or 0. And depending on how you do that will determine whether or not your sorted result will be in ascending order or descending order. So in the second example, I have swapped the A and the B. Now B is subtracted from A, and that gives us a sorted array in descending order. And that's more or less all you need to know about the sort method. You don't need to know how the algorithm is actually working. If you're interested, I will go into that in a later tutorial. But one other thing I want to show you is, what about when we're sorting on objects? So if you just try to run sort on an array of objects, it's not going to do anything, and that's not very helpful. So with objects, we'll always need to use a comparison function. And all we need to do is reference the key name that has the value that we want to sort by. So a.number in this case is equal to 1 on the very first iteration through the sort. And then b.number is equal to 2. And so 1 subtract 2 is equal to -1. And we know that a negative result will sort element A before B. So if this is A and this is B, then those will get swapped, which makes sense, right? Because 1 should come before 2 if we want our result to be in ascending order. So by the time it finishes all of its algorithm, we get the correct result here, 1, 2, and 3. And of course, we can once again prove that the original array was modified. Likewise, here I've done it again and flipped these around. So now b.number subtract a.number, and we have a result in descending order.